All right, so Kepler's third law, p squared equals a cubed. Remember, you got to have the right units for this. P has to be in years, A has to be in units called astronomical unit, where one astronomical unit is the distance between the Earth and the Sun, or really the average distance between the Earth and the Sun. It would take a long time before we were actually accurately able to measure that distance. We know what it is nowadays. It's 150 million kilometers. We know that very, very well, very accurately. All right, so this is something actually that Kepler thought about a little bit. The reason we know about this, of course, is because Kepler wrote lots of letters about these things, and wrote. He actually kept a personal diary as well that we still have, or at least portions of it. What this law says? Remember, this is also known as his harmonic law. He called it that himself. So let me read this part right here. The third law hints at a natural force holding the planets in orbit. So that, of course, we know what that force is nowadays. It's gravitation, right? Now here's the thing. Like, you gotta go back to more than 400 years ago, during the time of Kepler. I mean, Kepler knew about gravity. Everybody knew about gravity at the time. Gravity made things fall, right, on Earth. But nobody imagined that there was such a thing between planets and a star. That was completely alien to Kepler. But he certainly knew that there was going to be a force between the planet and the sun, right? Which is our star, of course. Instead of gravity, which he just imagined that gravity would just had to do with the Earth, right? That's what caused things to fall. Instead of gravity, he actually proposed, inaccurately. I mean, he wasn't right about everything. He proposed that it was magnetism, that there was a magnetic force between the Earth and the Sun. All right. Again, that's completely wrong. That's not what causes the planets to orbit the Sun. It's really gravitation. And we'll get to that shortly. All right. So the third law. Yeah, I already covered all that. All right. So and I'll do some examples with it. And yeah, we use the third law all the time. And it's very common. We'll find that in about a generation or so after Kepler, there's going to be a modification to this, and it becomes universal. It becomes this thing, p squared equals a cubed, works only for our solar system, only for objects that are in orbit around our star. All right. But what if something's orbiting something else with a different mass? Then there's a universal law that you can actually derive from Kepler's third law. All right, so it becomes basically it's going to be called the modified version of Kepler's third law. And of course, the guy that modifies it comes right after Galileo. All right, so Galileo is a contemporary of Kepler. They actually corresponded with each other. I don't believe they ever met. Galileo, of course, was an Italian. Kepler, a German, a Lutheran German, as a matter of fact. Very stoic. Kepler he was a very stoic individual. There's some other writing that we have about Kepler that describes him as a very stoic individual. What we know about Galileo is, Galileo is, first of all, very, very famous within his own time. Kepler, not so much. The stuff that Kepler discovered is, is shared among educated people of the time, but it doesn't really go any further than that. Galileo really sparks the imagination of the public with his observations. All right, so Galileo becomes like super famous, during his own lifetime. And the reason for that is he is the first one to turn a telescope to the night sky. He doesn't invent the telescope, mind you. Okay, so he doesn't. This is just a painting of him because they lived so long ago. There were no actual pictures, no photographs. Anyhow, sorry, no photographs. There certainly were pictures of him. They had drawings of him. So he doesn't invent the telescope, but what he does is actually almost as amazing. He actually hears about this device with two lenses, and he just hears about it, that it can magnify the image of objects. And so just from the word on the street, as it were, he actually builds his own telescope. Now the telescope that he builds is really primitive in comparison with the modern. I mean, if you have a pair of binoculars, more than likely your pair of binoculars is more powerful than Galileo's telescope. However, being the first one to look into the night sky with a telescope, he makes all sorts of discoveries that are not available to the human eye. All right, so one of the first things he does with his telescope is he looks at the moon. So he looks at the moon, and he sees craters on the moon. I mean, you look at the moon and you think to yourself, okay, like when we look at, you look at the moon in the night sky or during the day, and you know that there's craters on the moon, but it turns out that even the largest crater, there's a really large crater called Tycho, by the way. So the crater Tycho it's one of the largest on the moon, but even that large crater, this might even represent Tycho right here. That large crater cannot be seen with the unaided eye. So you really need a telescope to actually be able to see even the largest craters on the moon. All right, so there are craters. Now there are some dark areas on the moon called Maria. We'll get into why those are dark when we get to chapter 7. But so Galileo observes the moon, and he makes the following comment, which I think is absolutely important, although it doesn't seem scientifically important right now. When I state this, all right, it becomes important later on. So he looks at the moon and he sees, craters and mountains, and he compares the moon to the Italian countryside, which is a great moment in history, right? Before that, so the thousands and thousands of years before Galileo comes along, humans have been looking at the night sky. They've been observing objects. They've been looking at the planets. Of course, the planets are just lights in the sky that have this funny movement. But they looked at the moon. They saw the Maria. Even ancient people saw the Maria, and they saw the phases of the moon. But with Galileo's telescope, he sees that there's features. These rolling hills and mountains and craters and what he called valleys, which there certainly are on the moon. And when he compares it to the Italian countryside, it's the first time in history that humans that we know of anyway, that humans compare an object in the heavens, the moon, to something that's going on the earth, right? The Italian countryside. And suddenly, really a generation after Galileo, the moon is just another place, right? It's just another place in the universe, just like the Earth is a place in the universe. And I think that gets kind of skipped over in all these different discoveries that Galileo makes. That brief observation, or that comparison, if you will, between the moon and the Earth, is something that kind of escapes us now. I mean, nowadays we just think of, Mars is a different world. It's quite different than ours. It's smaller than ours. It's certainly much more red or orange than it's actually closer to orange. Than I know we call it the red planet, but it's actually more of an orange color. And anyhow, we normally think of the worlds as the other planets as just unique other worlds, but they were heavenly back 400 years ago, and Galileo begins to break that down into actual places that are unique and different from the Earth, and not perfect. That's the other thing is, these perfect circles, traveling in perfect circles. I mean, Kepler begins to chip away at that with the idea of that things are traveling in an ellipse. All right, so Galileo goes on and uses his telescope to make some other observations. One of the things he does is he looks at the sun. Now he doesn't look at the sun when it's directly overhead. I mean, he realized that would cause, that would really hurt him. He would just go blind. And in fact, just to let you know, he looks at the sun right at sunrise or right at sunset, very close to sunrise and sunset. And we have recordings or he wrote this stuff down. The problem is, so he does see sunspots. He notices that the sunspots are changing, and he notices that the sun is actually, or he deduces that the sun is rotating, because you can watch the spots and they change position. But the thing is, he does actually damage his eyes. It just takes a lot longer. If you were to look at the sun as it's directly overhead, I mean, even without a telescope, you would damage your eyes. So don't ever do that, of course. But he looked at the sun when it was really close to the horizon, but it was damaging his eyes. And towards the last 10 years of his life, he lived in his villa, well, he was actually. We'll get to this shortly. He was under house arrest, and he was completely blind for the last 10 years of his life. All right. So, but certainly before that happens, he makes some other observations. One is that Jupiter has these 4 dots. You don't always necessarily see all 4 of them, but on this particular night, you can see all 4 dots. And they change position night after night. These, in fact, he called them in the following order: Io, Europa, Ganymede, and Callisto. So those are the 4, and then nowadays they're called the Galilean moons. Those are the 4. There are many other moons around Jupiter, but these are the first 4 that you could see even with a small pair of binoculars or even Galileo's primitive telescope: Io, Europa, Ganymede, and Callisto. All right, we know a lot more about those things nowadays, but for Galileo, these were the first satellites, and they were that goes against Aristotle. All motion should be around the sun.